All right, the next section we're going to talk about, 10.2, has to do with arc measures. Arcs are pieces of circles. So everything we talk about here is going to deal with arcs and angles that form arcs. So the first thing we need to just make sure you're aware of is if I have an angle, these are the sides of my angles. This little piece here where those two sides meet is called the vertex. So you're going to see us talking about the vertex a lot in this section, and the vertex is just that point where those two sides of the angle meet, kind of like that corner there. So if we talk about a central angle first, a central angle is an angle whose vertex is the center of the circle. So it lies right on the center of that circle. So let me draw a circle with a center, and I'll use a different color to draw my central angle. So if I want to draw a central angle, again, vertex on the center, and it looks like this. So it's kind of like a slice of pizza. It's in the center, so it's central. It's in the center of that circle. Again, it's kind of like a slice of pizza. It's kind of like a piece of a moon or something like that. However, you can help yourself remember that that's a central angle. Another day, we're going to talk about another kind of angle that people tend to get confused. The next one is a minor arc. So a minor arc is part of a circle that measures less than 180 degrees. So again, I'm going to go ahead and draw a circle. Hopefully you know 180 degrees is half of a circle. When we talk about an arc, we're not talking about an angle like over here. An arc is actually like a piece of the outside, so it's almost like the pizza crust. So a minor arc, maybe I have a point here and a point here. The arc AB would be a minor arc. Even if I had one maybe like this, it's bigger, but it's still less than half the circle, so that's a minor arc. Again, it's like the pizza crust. It's not the pizza, it's the pizza crust that makes up an arc. The last part is a major arc, or the next part. Part of a circle that measures between 180 and 360. So it's more than half, and of course it's less than the whole circle. So if I draw my circle, a major arc just has to be more than half. So I could maybe go from here all the way around to somewhere like this. So the arc that looks like that, all the way from A to B, is a major arc. Again, it's more than half, but less than the whole circle. The very last one is a semicircle. So that's an arc with endpoints that are on the diameter of the circle. It has a measure of 180 degrees. So if I would draw this circle, here's my center. You guys know a diameter goes through that center directly across. So this is cutting my circle into two equal halves. So a semicircle is not this whole circle. A semicircle is this arc that makes up half of the circle. Again, when we talk about semicircles, we're talking about pizza crust. So this arc would be equal to 180 degrees. The next part of our notes has to do with naming arcs. So there's different ways you name a minor arc versus a major arc. Remember, minor arc is less than half. Major arc is more than half. Okay, so there's a difference between how you name those. The first one, minor arcs, so our smaller arcs, are named using 2 points. So it says name the highlighted arc and the type of arc, but you can't see the highlight on here, so I'm just going to highlight this arc here. If I was going to name that arc, that would be DF, and we just write a little arc over it. Kind of like a segment notation, but it's in the shape of an arc. I could also call it FD. Either way would be fine. And we know, of course, that that's a minor arc because it's in the minor arc section. But if you're asked to name the type of arc, you say it's a minor arc. Now, a major arc is named using 2 endpoints and a third point. So if it's a major arc or more than half the circle, you have to use 3 points. So if I highlight this big major arc, I need to use 3 points to name that. So it's going to be LMN or NML. The reason I have to name it that way is because if I just said LN, you're going to think I'm talking about this little arc. But that third point tells me that I'm going all the way around that circle. And that's a major arc. So minor arc, you use 2 points. Major arc, you use 3. Sometimes with a major arc, you don't have a choice. Maybe there's a point that's missing. You might have to use 2, but 99% of the time you're going to be using 3. Go ahead and flip over. Now we're going to get into measuring arcs. So minor arcs, we know the measure of a minor arc is always going to be less than 180, so less than half the circle. And to kind of throw in one of our other vocab words, you need to know the measure of a minor arc is the measure of its central angle. So remember, we said a central angle is like the slice of the pizza. Okay, so this is the angle opening here, opening to that arc. So if they want us to find the measure of arc DF, if I can tell what the measure of the angle that creates arc DF is, then I know the measure of arc DF. If angle E is 40 degrees, angle E opens up to make arc DF, so DF is also 40 degrees. Major arcs are a little bit more complicated. It says the measure of a major arc is 360 minus the measure of the related minor arc. So what that means is if we want to find the measure of arc LMN, so this big one we talked about in the last section, when I look at this, I don't know what this angle is. It's a huge angle and there's no number there to help me. But I do know the related minor arc, so the rest of the circle, is 110 degrees. If this red piece is 110, a circle has 360 total degrees. So this green part, the rest of the circle, has to be 360 minus 110, which is 250 degrees. It also works in reverse. If this arc is 250, this central angle is 250 as well. All right, we have two smaller parts left here. Part 4 is the arc addition postulate. So if you think back to one of our first chapters, we talked about angle addition postulate, segment addition postulate. Now we're talking about arc addition postulate. All we're doing is adding two or more smaller things to equal a whole. So this one says the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So it says find the measure of arc HE. So first of all, if I find arc HE, that's this one here. So I need to see, is there any way I can figure out what that measure is? If the angle, the central angle that makes that arc is 80 degrees, so again, angle HRE forms arc HE, then that arc also has to be 80 degrees. The measure of the central angle, so in here, is also the measure of that arc it creates. Now if I want to know the measure of arc GEF, notice it has 3 points, so it has to be a major arc. GEF goes the whole way around here. Well, to figure that out, I'm missing a lot of pieces. I know that this HE is 80, but I need to add in GH and EF. Well, if this central angle is 40, I know GH has to be 40. If this central angle is 110, I know this arc has to be 110, FE. So if I want this entire red piece, it's just going to be 40 plus 80 plus 110. And I get 230 degrees. So I'm going to go ahead and highlight that on my paper that I found that this entire piece here is 230. So that entire orange piece there is 230 degrees. And that's going to help me on my next one. Part C says to find GF. That's hard because I don't have anything about GF. That's the piece of the circle that I have left. But keep in mind, if we know the whole circle around is 360, and I know from G all the way around to F is 230, I should be able to take 360 minus 230 and be left with 130 for that GF piece there. So again, the whole circle is 360. If I subtract everything but arc GF, I'm left with arc GF, which is 130. Right, the very last one, it asked me for arc GFE. Excuse me. That's going to go, it's major because it has 3 points, from G to F all the way around to E. I just need to see what pieces of that arc that I have so I can add them together. Well, I know G to F is 130. We found that. So I also just need FE, which we found earlier to be 110, because this central angle is 110, so this arc has to be 110. So when I add those together, I get 240 degrees. So you just need to find what those pieces are of that arc and add the ones to form the arc you're looking for. All right, the very last thing we're going to do is talk about some problems with variables. And these are tricky sometimes because I can't tell you how to solve every single one. You have to look at the problem and see what you're given and see what you can find and just kind of reason your way through it. You need to fill in all the information that you can figure out first before you try to write some equation. So if I look at this first one at A, I can zoom in here a little bit. I see an x here, 17x plus 1. I know nothing about this arc, so that represents this arc here. I don't know the central angle, so I don't know what it's equal to, so I need to try to use the information around it to figure it out. I see this arc is 40. I know this arc, this piece of the arc has to be 80 because the central angle is equal to the measure of the arc. I see that this is 80, and I know that this has to be 40 because, again, the central angle is 40, so that arc is 40. Now, looking at what I have a term for every single piece of this circle, 40, 80, 80, 40, 17x plus 1. So hopefully you're thinking to yourself, I can add all of those up and equal 360. So if I take 17x plus 1 plus 40 plus 80 plus 80 plus 40, it equals 360. Again, because a circle has 360 degrees in it. Every circle does. I get 17x. 80 plus 80 is 160, plus 40 is 200, plus 40 is 240, plus 1 is 241, and that equals 360. So if I take 360 minus 241, I get 119 is equal to 17x. And if I take that divided by 17, I get 7 as my answer. All right, for part B. Now, if we try to go about this one the same way we did the last one, I'm looking and I have 3 pieces here, which is great, but I know nothing about these. Maybe you try to use vertical angles, so you know these will be the same, but then I'm still left with this big chunk I don't know. The one thing that people need to use more often and forget in these types of problems is semicircles. This is a diameter because it goes through that center point. And notice on this half of the circle, I have every single term, or I have a term for every single piece of that half circle or that semicircle. So if this whole thing equals 360, this whole thing should equal 180 degrees. So I can take 40 plus x plus 56 plus x plus 96 to equal 180. 96 plus 56 plus 40 gives me 192. X plus x is 2x, and that equals 180. If I subtract 192, 2x equals negative 12. And I get that x is negative 6. What you might be thinking is a little bit strange, but if you plug it back in, you get 50, 90, and 40, which works out perfectly. So looking at the next page here, you have some practice of naming arcs, finding measures, doing variable problems. So you're going to work on these tomorrow in class. So I have you stopping after you complete these notes. We're going to work on this practice tomorrow in class for period 2. Okay, for period 2, you're doing it in class tomorrow because we have a long class. Period 7, you are working on this in class because you're actually a section ahead of the other class. So period 7, you're completing this worksheet. The answer key will be online for you. Period 2, you're not completing this worksheet until tomorrow in class.